In today's video, we're discussing cold weather heading our way over the next couple of days, breaking down the possibility of snow showers from a clipper system, and focusing big time on a potential strong nor'easter that could affect the area late this week and early this weekend. All that and more coming your way right now. Hey, good afternoon everyone. John with New York Metro Weather. Happy Monday. We're here with your latest weather update video. We've got a lot to talk about today. It's starting with a clipper system and cold air this week and ending with the possibility of a major winter storm and nor'easter late this week. So let's get into it. And I know everyone really wants to hear about the storm later this week, but we're going to get through early this week first. Chilly out there today, but not as bad as it has been for the last couple of days. That's because we have this low pressure system that's developing just to our north and west. It's really weak and heading on out of here, but it did reduce the cold air flow into the region. You'll notice that models have most of the snow showers off to the north of the area through tonight, and that's really what we expect from tonight into Tuesday morning. The possibility of a couple of snow showers, but no real major accumulations. We'll check on the high resolution models just to be sure and take a look at it, and you'll notice that they agree with the European model here, with most of that snow shower activity remaining over northern Pennsylvania and the capital region of New York, and then moving into southern New England. So maybe if you're in Connecticut or parts of Long Island, you'll see the possibility of some rain or snow showers tonight into Tuesday morning. But for most of New Jersey and even the New York City metro area, very dry and really not too much going on other than a couple snow showers or sprinkles. Behind this system, though, temperatures are going to get chilly once again. So here's where we are this afternoon. You'll notice specifically in the New York City metro area that it's not as cold, not feeling as cold as it has been for the last couple of days. Once this system slides by, though, that cold will come back. So Tuesday afternoon, it's going to feel like the low to mid 30s across the area, maybe upper 30s along the coast. But by Tuesday night, here comes that cold swinging right back down again behind that system. It's going to feel like the single digits in the city. It's going to feel like below zero in the interior and in the higher elevations. Much of the same on Thursday, maybe even colder Thursday morning here with those real field temperatures in maybe 5 to 10 degrees below zero in the interior parts of New Jersey. And if you're up here in New England, even colder with that deep, deep cold settling into the area. And that's really it for the week. That leads us through Thursday and into Friday without any major precipitation events. We mentioned that clipper heading north of the area tonight into Tuesday morning. And that's really it. And so that allows us to segue into the thing that everyone wants to talk about, which is that storm threat late in the week. And so what I want to do is back up here and take a look at the pattern across the entire hemisphere, well, really North America, and just to explain exactly what's going on and why the storm threat exists. So there's a lot of colors and lines on this map, but let's break it down. We're looking at the mid levels of the atmosphere, so probably about 8 to 10,000 feet up. And the colors are vorticity, so that's the spin in the atmosphere. And basically we're looking at this vorticity and these heights in the mid to upper levels of the atmosphere to understand where the disturbances are and how they're tracking. And we're looking at an ensemble. So this is the mean of 50 different weather models in one. And so that gives us a good idea and allows us to kind of simulate what the mean of all the different possible solutions is. And we'll get more into the ensembles in a second. But we have a deep trough over the Northeast here Wednesday morning into Thursday. That's what we talked about, that cold air. It's helping to reinforce that cold from Wednesday into Thursday. And the first thing that catches our eye is this disturbance right here. It drops southward into really the Intermountain West region on Thursday morning. We have a big ridge here on the west coast, which is a feature of many of our big snowstorms. So this big ridge here on the west coast. This acts almost like a roller coaster, right? So these disturbances come down along the side of it and drop down into the United States. So models suggest that this first disturbance will be somewhere in this general vicinity of the Four Corners, Colorado, maybe New Mexico, on Thursday afternoon. And then we have a second disturbance right here. This is the key to it all, that drops southward very quickly out of Canada into parts of Minnesota and then down into the Ohio Valley, and eventually, according to some models, phases or merges with that initial disturbance, leading to a powerful storm system off the East Coast. However, there's a lot of ways that this can change, and there's a reason why all these models have a different idea as to what's going to happen. So to back up here, let's say, for instance, this disturbance here in the Four Corners were to be a little bit faster, right? And instead of being in the Four Corners, it were to be here in Texas or Oklahoma or Kansas. All of a sudden, this disturbance, right, would come down here and phase, and the result would be different because this would be located somewhere else. So the storm track and where the storm deepens and strengthens would be different. Let's say also that this disturbance right here was a little further west, right? Instead of being here in Colorado or New Mexico, it's back here in Arizona. then this disturbance that drops down out of Canada would have a difficult time phasing with it at all, right? Because it would be trailing all the way back here, and it would miss the phase, and the storm system likely wouldn't happen at all. The storm would head out to sea. That's just one variable, right? That's just one disturbance. This northern stream disturbance could behave slightly differently as well. Instead of dropping down here into Minnesota, it could head eastward into maybe Michigan. And all of a sudden, the phase happens way out to sea, way further east. Or it could come down a little further west and phase here over the Ohio Valley and cause the storm to come back further west towards the coast. What I'm trying to get across here is that we have a very intricate phase and interaction of two disturbances occurring. The first one ejects here from the Intermountain West into the Mississippi Valley, and it ends up right in the Mississippi Valley here on Friday morning. And the second one comes all the way down from the Arctic through central Canada and down into the United States, and eventually phases with this second disturbance and forms a strong storm off the East Coast. If those two things happen perfectly, as many models are suggesting right now, we could be looking at a very powerful storm. Let's zoom in and look at what's going on across the United States to get a better idea, right? Here's disturbance number one. Comes into Colorado and ends up moving eastward. You can see here there's some spread among the models. They don't really know exactly what's going to happen yet with this disturbance. Some of them are keeping it back here. Some of them are moving it into Oklahoma. This is going to be a major issue with the forecast and to whether or not this phase is going to happen. Most of them, though, suggest it will move here into the southeast states, and our next disturbance will come down, phase, interact, boom. You get a major storm system developing up the East Coast. And eventually forming a strong low pressure system off the East Coast. This is the European operational run. So we mentioned the difference between the ensemble and the operational. Here's an ensemble, right? This is a blend of 50 different weather models. And here's one operational model, one of 50. And you can see the suggestion here that part of this disturbance gets left back here in the southwest. But despite that, some of it makes it into this trough. This northern stream disturbance comes down, phases, tucks it into the coast, and all of a sudden you have a very powerful storm. If we operate under the assumption that this will happen, right, we know the possibility exists that this phase isn't going to happen so cleanly as models suggest. But if we operate under the assumption that it does happen, the jet dynamics that are in place here are extremely impressive. On the European model, we see this rapid expansion of a dual jet structure across the eastern United States. Fancy words for a ton of divergence aloft and really support for a rapidly strengthening low pressure system. Look at how this jet blossoms into a dual jet. Here we have this strong jet stream, and once that phase occurs, look at the blossoming of the jet stream. This is just perfect to encourage rapid deepening of the surface low and major precipitation on the European model if that phase happens like the European says it will. Zooming in back in on the ensemble members, we see that a similar signal exists. So we have this very strong signal for a strong storm in the eastern United States on the ensembles, and the individual members agree with that. We see a lot of them producing a strong low pressure system here off the East Coast, developing northward close to that 40-70 lat long benchmark that all is discussed very often when it comes to northeast U.S. snowstorms. But I want to again hit on the differences amongst these models. This is 120 hours away, so this is valid for Saturday morning, but the spread amongst the possibilities here is tremendous. And I also want to hit on the intensity of some of these. This is a 952 millibar low off the coast of Maryland, 971, 982, 986, and as we move further north, 952, 969, 974. These are all very strong low pressure systems on these ensemble members on the European model. And so the suggestion is very strong from the ensembles that we are going to have a major nor'easter on Saturday. Again, granted that this phase occurs, there are still some members, if we scroll down here, there are still some members that say, hey, wait a second, we're not so sure this phase is going to happen the way that other models have it. And they slip this storm way out to sea. It's not one or two members, right? It's probably 10 of them, maybe more, that slip this storm out to sea. The large majority of them are up here. But we just want to talk about the possibilities that exist here. And even if that phase does occur, we see there's a spread of a couple hundred miles as to where this storm is going to track. Now, we talked about this spread here from west to east. Why is that important? Because if we go back to the operational European run and we look at what it shows in the northeast states, we can see that eventually this storm starts to come up the coast and it amplifies. But how exactly does it do that? Here's a European model. You see the storm is going to develop here. This is Saturday morning, and here comes the low pressure system, right? How much does this precipitation field expand, right? When this low pressure strengthens, does it just clip the New York City metro? Are we right on the fringes? Or is this low pressure further west, like some of those ensembles with New York City right in the crosshairs of the heavy snow? It's going to be very close. And so when you go back to the ensembles and you look at this spread here of a couple hundred miles from west to east, all of a sudden you start thinking to yourself, hey, wait a second, that's the difference between probably a huge snowstorm and maybe New York City being just on the fringes of the snowstorm. And so that's just, part of the reason why we use these ensembles, because you have 51 different members and you can get an idea as to what the spread in possible solutions is among those ensemble members. Going back to one of the features we looked at before, I don't want to focus on the snow totals, but I just do want to focus on the individual members here and just poke around to see and kind of explain that variance to you guys. So here, if we look at 25 different members, this one shows a major storm. This one's mostly a miss. Here's a major storm, another major storm, another major storm. Here's another miss, a couple more major storms, another miss. And so what I'm trying to get across is that even though this signal is there for a very strong storm, in the New York City metro area, it's not so clear-cut yet exactly what the impacts will be. That being said, I do want to get across that this is a powerful, strong storm signal, and the possibility does exist for a significantly impactful event from Friday into Saturday. And over the next couple days, we're just going to have to break down how these ensembles look and where the storm looks to track. Again, just to revisit one more time, a lot of it is going to come down to how this phase occurs right here between this initial disturbance and this next one dropping down from Canada. How they phase when and where will determine when that low pressure gets tucked in towards the coast and strengthens rapidly. And over the next couple of days, we're going to have to watch very carefully how models are handling that. So with that, let's get to some questions. And we had a bunch of really good questions on Twitter and social media, so let's dive into them. One of the first questions we got was, is there enough high pressure this time to prevent the movement of warm air into the New York City metro area? As things are modeled, the answer is yes. Let's look at the ensemble mean. We see this broad high pressure system to the north of New England here, and our low pressure system forming here close to the coast. As that storm moves up and the phase occurs, the high pressure only strengthens to our north. You can see that really reinforcing the cold air to the north of New England. So yes, if the phase is clean like the models show, then yes, the high pressure is right there and there to help reinforce the cold. However, if the storm continues to trend further to the west, we might be looking at introducing some precipitation type issues along the coast. It's a little early to start talking about that, but all the ingredients are there in terms of the high pressure to keep this storm off the coast and keep it a colder than normal storm for the New York City metro area in general. But we're going to have to watch at exact track. Again, it's going to come down to specifics, which are going to take a couple days to figure out. Another question we got was, is there a potential for a snow or work from home day? That's really hard to say because the majority of this event looks like it's going to occur on a Saturday, if it does occur at all. So maybe Friday afternoon and evening, but the models really don't amp this up until late Friday into Saturday. This is valid Saturday at around 8 a.m. with that low pressure really cranking off the coast. So it's really hard to say. If you do work weekends, maybe the possibility exists, but that's kind of out of our area of jurisdiction, and it's going to depend on exactly what your job is and what the situation is with what you're doing. But this is looking like a weekend event as it stands right now. Another question we got was, is there potential for a squall? Well, this storm system really isn't necessarily one we'd associate with a squall. This is more of a synoptic storm. The snow intensity, the precipitation intensity, could be compared to that of a squall. When you look at these very intense dynamics that are occurring in the upper level jet stream, if we go back here and look at the European model individually and pull this up, we'll see as we go into zoom in on New England that a lot of this banding that does occur on this specific model run is pretty intense. You can see it right here as simulated. Again, it's just one model run, but as simulated on Long Island and into southern New England. This is intense snow, so it's likely falling very heavily and similar to that of a squall, but this is more of a synoptic cyclone and less of what we would define as snow squall. But yeah, if you're talking about heavy snowfall rates, the potential definitely does exist for that with this system. Another good question we got, a couple more here. What is the potential for wind and or blizzard conditions? So we're not going to get too much into the blizzard stuff because we don't really know exactly where the storm's going to track. But if the ensembles are correct in simulating a storm system with this kind of dynamic approach and this strong low pressure, the possibility would exist for strong winds near the coast. You can see this operational run showing those strong northerly winds, and especially near the coast here on Montauk and then eventually Cape Cod and areas like that. wherever the storm tracks is going to depend on where that is. But this is a windy system. You can see the model really signifying the dynamics and insinuating that there's some very strong winds associated with this storm. So I think that's a good point to bring up, because it's not just about the snow, it's about the impacts elsewhere as well. And this storm could produce some pretty significant winds. So we're going to have to watch for that as we start to pin down the exact track moving forward. So that about wraps it up for the questions. We are going to just run through this one more time. Again, the potential exists for a significant storm this weekend, but there are a lot of parts moving around here, and we want to just reiterate. It's going to come down to how these two disturbances interact. Here's our first one, simulated Thursday afternoon. It drops down into the four corners, right? It eventually will slide to the east here. Exactly how it does that is going to be critical. Here comes our second disturbance, dropping south from Canada into Minnesota and eventually the Ohio Valley. The models as of today suggest these two will phase. They will interact, and this first disturbance will get tucked up the coast, and you'll get a powerful storm. But it'll only take very slight changes in how these evolve to change the outcome of the system. If they don't phase as cleanly, the storm itself will likely end up further east and out to sea. And if they phase sooner, it'll likely be tucked in closer to the coast. Still a lot of variance into how the models suggest this is going to behave. But the potential is on the table for a powerful storm. We'll be with you for the next couple of days, breaking it all down. We'll likely get much higher confidence in the details of how this is going to go down over the next couple of days, so Tuesday and Wednesday, as we check out the latest model guidance moving forward. Thanks again for watching. Please subscribe if you haven't yet, and make sure to share our YouTube channel. We'll be back tomorrow, Tuesday, with more updates on the potential strong, significant winter storm this weekend. Thanks for watching, guys. Take care.